So the tools of game theory are used in a wide variety of applications, both in economics, within economics, but also in many other disciplines. One of the things we have used have used game theoretic models to study is the question of monopolistic competition, and there we use models to understand location choice by monopolistically competitive firms, but we also use location choice as a metaphor for choosing product characteristics. So instead of miles away from some point or location on a beach, as my example in the screencast is going to do, we could think of, say, soda pop flavors, intensity of sweetness, the fizziness, and we can think of locations along a spectrum: more sweet, less sweet, fizzier, less fizzy, etc. And we can use locational models for those. But anyway, let's go on to the question in the text and the discussion of why it is that we tend to see firms clustered together when intuitively it seems more logical that they in certain circumstances might spread out a bit. But the game theoretic model can help us understand that. The guy that first thought about this is a guy named Hotelling. I believe he's another French economist. Anyway, he thought of this case. Let's suppose there's a beach that's a mile long. So we could think of all the locations on the beach from point 0 to the point at 1 mile. And let's in particular suppose that there's 3 possible locations for an ice cream stand or 2 ice cream stands. And these 3 locations are at 0.25, 0.5 miles from this ground zero, and 0.75. And our intuition might suggest that the best place for ice cream stands would be at 0.25 and 0.75, and that way, they share the market. We assume that beachgoers will go to the stand that's closest to them, and they split the market 50-50, and beachgoers have to walk as short a distance as possible. An interesting proof is to prove that the locations at 0.25 and 0.75 would minimize the distance walked by beachgoers. So we would tend to think of firms spreading out. And so in a monopolistically competitive case, this would be a world where some sodas were really sweet and some were not so sweet, and etc. But we're going to see with our game theoretic model that there's a tendency to cluster. So in mass market beer, sorry to use this analogy or this market again, but instead of seeing a variety of choices made by mass market beer producers, they all tend to be clustered in this sort of blandy piss water taste. And political, we use this model to understand political campaigns. Instead of staking out different positions, the politics, at least in the final national election, the politicians tend to choose very similar platforms, Republican or Democrat in the United States. And this model is the one we use to describe the forces in play that bring about this result. So let's go forward and think about this location of, let's suppose there's 2 stands that are thinking about where to locate along this beach, and let's think about where they're going to locate. And we're going to use a game theoretic framework, so that means a payoff matrix. This presentation differs slightly from the one in the text. All right, so here's what's going on. We've got this beach. This is this 1 mile long beach. We've got 3 possible locations: 0.25, 0.5, and 0.75. And so I've made my payoff matrix. There's shop A, there's one player. Shop B, they're going to choose location. So I've got my players. Their possible moves are to locate at 0.25, 0.5, or 0.75. Same B faces the same choices. And then in this grid are the payoffs, and lower left is going to correspond to shop A's location, payoff. and the upper right is going to correspond to shop B's location payoffs. For the case, this cell is going to be the payoff if shop B locates at 0.25 and shop A locates at 0.25. And we're going to write payoffs in terms of just market share, and we're going to assume that people walk to the stand closest to them. So the market shares are, I'll express them in percents and talk you through them. Here we go. So let's think if they both locate at 0.25. Well, these people have to walk a long way, and these people not so much, but they find both stands, one next to another, and they split the market. 50%, 50%. All right, but let's think if shop A is located at 0.25 and shop B locates at 0.5. Well, now we assume people go to the one closest, so half these people in this stretch between A and B, half go to A, half go to B, but all these people go to B, and A's captive market is only this group. So you could do the math, but there's 0.25 miles along this stretch, and we assume beachgoers are evenly distributed along the beach. There would be 12.5% of the beachgoers right there. So 50 plus 12.5, shop B is going to get 62.5% of the market, and shop A is only going to get 37.5% of the market. And if the situation were reversed, shop A at 0.5 and shop B at 0.25, there's a symmetric game. In that case, shop A would get 62.5 of the market share, and shop B 37.5. So with that logic expressed, we can move a little faster. If they're both at mile 0.5, they get 50 each, 50% each. And if they're both at 0.75, they get 50% each. And if one's at 0.75 and one's at 0.25, they get 50 each. So that's shop A at 0.25, shop B at 0.75, they get 50 each. And the same thing if shop A were at mile 0.75 and shop B at mile 0.25, we'd see a 50-50 split. And then that leaves us the case where shop A is at 0.75 and shop B at 50 at 0.5 miles. That would be another case where A gets this smaller market, B gets this larger market. So B would get 62.5 and A would just get 37.5. And it's a symmetric game, so if B were the one over here and A were the one here, sorry to scribble this up, we would see A with the big market share, 62.5, and B with a smaller share, 37.5. Well, now we're in position to solve this game. Let me change my color, and we'll go with orange. And let's think about this. Let's take it from shop A's perspective. Let's suppose A thinks that shop B is going to be at mile 0.25. Well, shop A could locate at mile 0.25 and get half the market, could locate at mile 0.5 and get 62.5% of the market share, or at 0.75 and get 50. Well, they're maximizing market share, so in that case, the A's best play is to locate at mile 0.5. Now I'll change color. Let's think about the case where A thinks B is going to locate at 0.5. All right, well, A could locate at 0.25 and get 37.5% of the market. A could locate at 0.5 and get half the market, or A could locate at 0.75 and get 37.5 of the market. Well, 50 is the highest here, so again, we're going to see A's best strategy is to locate at mile post 0.5. And then finally, let's pick another color just to take this home. Let's use green. If A thinks B is going to locate at 0.75, A could locate at 0.25 and get 50, 0.5 and get 62.5, or 0.75 and get 50. And again, we see A would do best by locating at 0.5. And so A has a dominant strategy to locate at location 0.5. Where it's a symmetric game, so it turns out B has a dominant strategy to locate at 0.5, and lo and behold, this game ends with both clustered in the middle, and the sellers split the market, and okay, they split the market, but remember that from the point of view of society, I'm going to go back a page here. From the point of view of society, it would be best to have one at 0.25 and the other at 0.75. It doesn't really matter which is which. Yeah, both sellers are just as well off if they locate there because they each get 50% of the market. But the desirable feature of this spread out location is that citizens have to walk the least distance to get to the ice cream stands. But we see that the dynamics of the market instead leave both clustered in the middle, and everybody's got to take a longer walk on a hot day. And so, those of you who are just knee-jerk, the market always gets it right, this is a good, simple case where we see that the market dynamics actually get it wrong. And some, not to say there aren't risks of having an activist government. That's certainly a risk that one has to consider. But at least in theory, we could have a government that said, hey, look, you get this permit to be at 0.25 and this other vendor has a permit to locate at 0.75, and the firms are just as well off, but now citizens have to travel less. And of course, this is just one explanation. There are a couple other ones that I can go into if you're curious, but I want to keep this screencast from getting too long. I'm going to close with this one last picture, though. It's sort of funny. In the modern day, if the beach allows vehicle traffic, or at least certain vehicle traffic, we can have an ice cream van and solves the problem for everybody. So maybe that's the market solution that makes the location a moot point.